Have you ever heard about domestic water heating? I guess it's not familiar in you, but I'm sure that you have been getting benefits from it by simply taking a sip of coffee, taking a hot shower, cooking, and many more. Other typical domestic uses of hot water includes cleaning and space heating. If you're thinking that water heating only applies to that, then probably you are wrong. You're not just aware how important and how wide it is. It can also be used in generating electricity, which is very essential in the modern world. Also, hot water and heated to steam have many uses in industry. Now, let us come in the brief history of water heating. Before, when water heating is not yet practiced, people don't bath much because of the cold water. Rather, they mask body odor with perfumes and oils or just went around smelly. Even as recently as the turn of the century, running hot water was a luxury. A personal supply of hot water is thought of as a necessity. Now we come on the ways of heating. From stove to storage tank, hot water in an instant, early solar and tank evolution. This shows how time changes us and how certain things can become useful in the modern world or in the future. Before, water heating requires manual effort, but in these days, almost all are instant. Inventions of technologies are at play today. Now, we come on defining the domestic water heating. But let us define first water heating. So water heating is a thermodynamic process that uses an energy source to heat water above its initial temperature. From that definition, we can say that the domestic water heating is the process of warming water for personal use and it consumes a large amount of energy. Because the higher the temperature of water is, the more the energy it consumes. The importance of domestic water heating is that it provides the supply of heated water to your taps and plumbing fixtures on demand. Without a hot water heater, you would be required to heat water manually when bathing, washing, and many more. Another term that needs to be defined is water heater. It is an appliance or system that heats water for domestic or building service water use. It includes electricity, natural gas, propane, and oil. Putting it in a simpler definition, water heater is an apparatus for heating and usually storing hot water.
There are 6 types of water heaters: the storage tank water heater, the instantaneous water heater, the circulating water heater, heat pump water heater, solar water heater, and the superheaters. Let's first tackle about the first one, the storage tank water heater. The storage tank water heater consists of a storage tank and a heating medium. It also varies in sizes including 30, 40, 50, 60, 65, 75, 80, 100, and 120 gallons capacity. They are available in natural gas, propane, fuel oil, and electric models. An average size 3-bedroom residence uses a 50 gallons water heater. Electric water heaters have coil-like elements that extends into the tank, which heats water as electric current passes through the elements. Gas and fuel oil-fired water heaters have burners located at the bottom of the tank and a vent that passes up through the center of the tank. We have 3 types of storage tank water heaters: the residential, commercial, and the ultra-efficient water heaters. The residential storage water heaters are designed for the residential market. but can be appropriate for many small commercial facilities. These water heaters are available in tank sizes up to 120 gallons and gas inputs up to 75,000 British thermal unit per hour. They are relatively inexpensive and widely available because they are manufactured in large quantities. The next one is the commercial storage tank water heaters. The commercial storage tank water heaters are similar to residential models except that they are available with much higher gas input ratings up to 1 million British thermal unit per hour or more and larger storage tank up to 250 gallons. They also feature larger pipe connections, more rugged control, and a few features that are only rarely found in residential heaters, such as flue dampers and electronic ignition. By the way, for those who do not know what a flue is a duct for smoke and waste gases produced by a fire, a gas heater, a power station, or other fuel burning installation. Its purpose is to harmlessly direct and discharge the toxic flue gases into the chimney. The last one is the ultra-efficient water heaters. Ultra-efficient water heaters use power burners and enhanced heat exchangers to force hot combustion gases into chambers and tubes that are submerged in the stored water. Ultra-efficient water heaters are vented with plastic pipes that go directly through an outside wall. Because they draw combustion air directly from outside, through one of those pipes, their combustion processes are sealed off from the occupied space. Thermostat. A thermostat serves as a control of the heating medium. It switches the heating medium on when the temperature of the water in the tank has cooled below a set point temperature, and switches the heater off when the water in the tank reaches the preset temperature setting. A storage tank is insulated to reduce standby losses. Storage tank water heaters have 4 classifications. Number 1, non-venting, wherein it uses electricity. Number 2, naturally aspirated water heaters. Naturally aspirated water heaters have a flue that runs vertically through the center of the tank. Products of combustion are vented by relying on the natural buoyancy of the flue gases. Number 3, power vented water heaters. Power vented water heaters use a fan to exhaust flue gases. Number 4, sealed combustion water heaters. Sealed combustion water heaters have supply air and exhaust air connections to the outdoors. These units do not require any indoor air to operate. There are 2 types of sealed combustion water heaters. Some units have a flue up the center of the tank, while the other type is the unit that has a heat exchanger that wraps around the tank.
So let us now proceed to the instantaneous tankless water heaters. This is very common in the Canadian homes. It is also called as the demand water heaters, for the need of hot waters by the people is continuous. They have heating device that is activated by the flow of water when a hot water valve is opened. So it is more efficient because it consumes less space, for it has no tank. Instead, the internal sensors inside the heaters control the flow of hot water. It is available in natural gas, LP, and electric models. Sizes for different applications such as a whole house water heater, a hot water source for a remote bathroom or hot tub, or as a boiler to provide water for a home heating system. Instantaneous point-of-use water heaters fit compactly under a fixture, example, sink or lavatory, and heat water at the location where it is used. So tankless water heaters only generate heat water when it is needed. Compared to other heaters, it produces 300% more heat, but it costs more, that's why it's not for everyone. Circulating water heaters, it is consist of a separate storage tank that stores water heated by a heat exchanger. Tankless coil and water heaters. Tankless coil water heater, it has no separate storage tank because water is heated directly inside the boiler in a hydronic heating system. While in direct water heater, it has a separate storage. Like the tankless coil, indirect water heater circulates water through a heat exchanger in the boiler. Heat pump water heaters. It extracts energy from outdoor air and uses it to produce hot water very efficiently. It uses an electric motor to run a compressor. Heat pumping process heats the condenser and cools the evaporator. It requires installation in locations that remain in the 40°, 90° F range year-round and provide at least 1,000 cubic feet of air space around the water heater. Solar water heaters. It is also called as the solar domestic hot water systems. It includes collections mounted on the roof or in a clear area of the yard. A separate storage tank neat the conventional heater in the home, connecting pipes and electronic controller. These are usually used to preheat water using a conventional heater after. We have two types of solar water heating system. Active solar water heating systems have circulating pumps and controls. It has subtypes. Direct circulation systems. Pump circulates household water through the collectors and into the home. Another one, indirect circulation systems. Pumps circulate a non-freezing heat transfer fluid through the collectors and heat exchanger. For the second type, we have the passive solar water heating systems. These are typically less expensive compared to the active solar, but they are usually not as efficient as the active solar water heating systems. It also has its subtypes, the integral collector storage passive systems. These work best in areas where temperatures rarely fall below freezing. The thermosiphon system. Water flows through the system when warm water rises as cooler water sinks. We also have the superheaters. It is attached to an air conditioner or heat pump that allows waste heat from that device to assist in heating domestic water. In hot climates, a superheater can provide most of a home's hot water needs. We are now going to proceed to the comparison of electrical water heater and solar water heater. So from what I mentioned a while ago, pag solar water heater, nagre-rely po sila sa heat of the sun. While the electrical, from the word itself, it is based on electric current. So pag solar, we have a cheaper annual cost. Siyempre, cheaper yung annual cost, mayroon tayong less electricity bill. It is also considered to be more economical in long term. So, hindi po siya pang short term na mapuputulan ka if ever you will not be able to pay bills since po, lesser lang naman po yung electricity bill natin if we prefer to use solar water heater. So, dahil po doon, it is also suitable for a big family and it is also renewable nature and environmental friendly. So let's proceed to electrical. So pag electrical naman po, it will give us greater annual cost which will increase our electricity bill and it is less economical in long term. And it also gives us more consumption, more cost. So kapag madami yung gamit mo ng pag mahilig ka talaga sa mga maiinit na tubig or it is very in demand to you, di ka nakakaligo. Siyempre, more cost po siya kasi nagko-consume po siya ng electricity. It is also non-renewable and non-energy efficient.
Energy efficiency. A standardized measure used to express the efficiency of residential heaters, developed by the U.S. Department of Energy. It represents the amount of heat required to warm up hot water for a typical home in a year, divided by the amount of energy input into the heater to warm that water. The higher the EF, the more energy efficient the water heater is and the less energy consumed. So when you're going to buy a water heater, go with the one having a high energy efficiency rating. High efficiency electric water heater are those with EF ratings of 0.90 or above. For storage tank water heaters, 0.95 is the upper limit. So basically, the energy efficiency tells us how efficiently the heat transfers heat energy to the water. Coefficient of performance. It is a measure of the instantaneous energy output of a system in a comparison with instantaneous energy input. The coefficient of performance of a standard hot water system is close to 1, and the COP of a typical heat pump water heater may be 3. In other words, it is the ratio of heating or cooling provided to the work required. The most basic formula to this is Q over W, where Q is the heat supplied or removed from the reservoir, and W is the work done by the heat pump.
Hot water recirculating systems ensures that hot water is always available at the taps, thus avoiding the need to run water for a long time to obtain water at the desired temperature. A hot water recirculating system continuously circulates hot water from the water heating unit through the hot water supply piping and back to the water heater through hot water recirculating piping. 3 types of hot water recirculating strategies. Number 1. Continuous recirculating. Water is constantly recirculated from the water heater through the piping. It is best suited for buildings having round-the-clock occupancy. Number 2. Timed recirculating. Involves use of an electronic or electromechanical timer to shut off circulation of hot water when the building is not occupied. Number 3. Thermostatically controlled recirculating. Relies on a sensor located at a remote location in the recirculating line, which senses water temperature and activates the recirculating pump when water temperature drops below a predetermined setting.
So, in determining water heater size, design load. A water heating system must be designed to have sufficient capacity to provide hot water during periods of peak use. So it tend to be in peak in the morning hours and again in the early evening. An accepted method of determining the maximum demand on a water heater is to determine peak usage during a particular time of day. So this is a table for estimated typical hot water demands based on use. So as we can see that the highest demands on hot water per use is the automatic clothes washer, which has a 122 liter. So next table is the typical hot water demands for various types of buildings. So in type of buildings, we have the number of apartments. 20 or less has the highest demands on hot water average per day, which has a 159 liter average per day. So just take note that the average gas-fired residential and light commercial heater is 30,000 to 75,000 BTU per hour with recovery rate of 27 to 68 gallons per hour. So natural gas-fired water heaters is 35,000 with recovery rate of 31.5 gallons water. And water heaters powered by electricity with recovery rate of 1 gallon per hour and per 250 watts. So common residential electric water heater 3,000 to 4,500 watts with recovery rate of 12 to 18 gallons per hour. So recovery rate of a gas-fired water heater is typically about the rate of electric-powered units having the same storage size. So electric water heater storage tanks are larger, and FHR of water must meet or exceed the peak hot water demand. So this is guides in selecting the minimum gas-fired storage tank water heater size in gallon. So the number of bathrooms, 1 to 1.5, we have 2 to 2.5, 3 to 3.5. So these are the following data that should be followed. Excuse me. And next is in the oil-fired. Oh, the first one is in gas-fired. This is in oil-fired. So, the storage tank capacity, the first hour rating, and we have here the energy factor in oil-fired. And this has always, or this should be followed. Same as here in electric. So, next is sizing instantaneous water heaters. So, instantaneous water heaters are selected based on the amount of hot water needed to meet the design load or the peak instantaneous demand in GMP or gram per or liter per minute at a specific water temperature rise and criteria. So, specifications for selected gas-fired instantaneous or tankless water heaters and customary units compiled from industry sources. So, just take a look at the table. Okay. So, next is the design load. Again, it was mentioned already in earlier, yes. So, the flow rate of the instantaneous water heater is determined by adding flow rates of fixtures used simultaneously. So, the following assumptions on water flow for various residential fixtures may be used to determine the size of units. So, for the faucets, we have 2.84 liter per minute to 9.46 liter per minute. So, for low flow shower heads, 4.54 liter per minute to 7.57 liter per minute. So, the older standard shower heads is 9.46 liter per minute to 13.25 liter per minute. So, clothes washers is 3.79 liter per minute. And in washers, we have 7.57 liter per minute. So, in good assumption in designing instantaneous water heaters, so for incoming potable water, no warmer than 50 degree Fahrenheit or 10 degrees Celsius or not warmer. So, in cold climate, so the temperature should be 35 degree to 40 degree Fahrenheit, 2 degree to 4 degree Celsius. So these are another is for residential uses, typically be heated to 120 degree Fahrenheit or 49 degrees Celsius. So these are temperature for us to be able to make a good assumption in designing instantaneous water heaters. So, to determine the required temperature rise needed, subtract the incoming water temperature from the desired output temperature. So, temperature rise at least 70 degree Fahrenheit or 39 degrees Celsius. So, we have here another table which shows, or it is the test results of flow rates of various rises in temperature for a selected residential gas-fired instantaneous water of 66 Fahrenheit heater based on an inlet temperature. So we have the delivery temperature rise, and flow rate or liter per second. So for 180 degree Fahrenheit or 82 degrees Celsius, the temperature rise is 114 degree Fahrenheit or 46 degrees Celsius. And the flow rate, liter per second, is 9.5.
Size of an instantaneous water heater shall meet the following conditions. One hot water faucet open with a flow rate of 0.75 gallons per minute or 2.84 liters per minute. One person showering using a shower head with a flow rate of 2.5 GPM or 9.46 liters per minute. An inlet water temperature is 40 degrees Fahrenheit. Water must be heated to 120 degrees Fahrenheit. The design load is found by 0.75 gallons plus 2.5 gallons is equal to 3.25 gallons. The required temperature rise is found by 120 degrees Fahrenheit minus 50 degrees Fahrenheit equals 70 degrees Fahrenheit. An instantaneous water heater with a flow rate of no less than 3.25 GPM or 12.3 liters per minute at a temperature rise of 80 degrees Fahrenheit, 3.26 should be selected. Utilizing a large multi-family water heating system. In large multi-family dwellings such as apartments or condominiums with 10 or more units, hot water demand tends to peak between 6 and 9 a.m. and again between 5 and 8 p.m. An approximation method used to determine hot water demand in large multi-family buildings, 10 or more dwelling units, is based on the demand unit. Demand unit is counted for each bathroom and clothes washing machine served by the water heating system. For apartments or condominiums with 10 or more units, maximum probable demand of hot water in gallons per hour, MPD, is equal to 350 plus 11 times DU. This expression assumes 11 gallon per hour for each demand unit plus a 350 gallons per hour reserve capacity. For 24 condominiums, each having 2 bathrooms, 48 DU. For 4 clothes washers, 4 DU, total of 52 DU. The MPD is equal to 350 plus 11 multiplied to DU is equal to 350 plus 11 times 52. This gives 922 gallons per hour. Capacities of cylindrical storage tanks. Table 13.22 shows water heating demand units versus storage tank capacity per demand unit. Number of demand units 0 to 10, gallons per demand unit 30, liters per demand unit 114, 11 to 25, gallons per demand unit 25, liters per demand unit 95, 26 to 50, this gives gallons per demand unit of 20, liters per demand unit of 76, over 50, this gives gallons per demand unit of 15, liters per demand unit of 57. The minimum storage tank capacity in gallons or STC is equal to demand unit multiplied to gallons per demand unit. Calculate the minimum storage tank size for a water heating system for the 24-unit condominium described in the previous example. Select a tank size based on a height of 7 feet. From the previous example, the total DU is equal to 52. From table 13.22, the 52 DU should be computed at 15 gallons per DU. From table 13.23, for a minimum capacity of 780 gallons and length or height of 7 feet, a 54 in diameter by 7 feet gallon tank is acceptable. STC is equal to DU times gallon per DU, or 52 times 15, and this gives 780 gallon minimum.
So we're now going to proceed to the distribution systems. It is the configuration of piping that delivers hot water from water heater to the end use points within the building. So we have the types of systems serving single dwelling unit, and later on we'll discuss about the types of system serving multiple dwelling unit. So for the first type, we have the standard distribution system, or the trunk and branch and mini manifold configurations. So it is the most basic plumbing layout, and assumes the reference design in the performances approach is presented by the conventional trunk and branch layout. It includes 1 or more trunks, each serving a portion of the building. For the installation criteria and guidelines, no pumps may be used to recirculate hot water with the standard system. Keep all segments of the system as short and as small a diameter as possible. Even an insulated pipe will lose most of its stored heat within 30 minutes. So for the second type, the central parallel piping systems. It is an insulated main trunk line runs from the water heater to 1 or more manifolds, which then feeds individual use points within 1/2 inch or smaller plastic piping. The traditional central system with a single manifold must have a maximum pipe run length of 15 feet between the water heater and the manifold. For the installation criteria and guidelines, the intent of a good parallel piping design is to minimize the volume of water entrained in piping between the water heater and the end-use points. So focus on reducing the length of the 3/4 inch or 1 inch line from the water heater to the manifolds. No more than 5 feet of piping between the water heater and the manifolds. The manifold feeds individual hot water use points with 3/8 or 1/2 inch PEX tubing. So for the third types, we have the point of use. It reduces the volume of water heater between the water heater and hot water use points. It requires a combination of good architectural design, an indoor mechanical closet, or the use of multiple water heaters. So for the installation criteria and guidelines, all applicable mandatory features must be met, and the distance between the water heater and any fixture using hot water cannot exceed to the length of the specified table in the previous slide. All water heaters and hot water fixtures must be shown on plans submitted for local building department plan check. For the exemption, we have the washing machines for clothing may be located more than 8 feet from the water heater. For the compact design, all the hot water use points in a non-recirculating distribution system are within a specified length of piping to the water heater that serves those fixtures. And lastly, we have the recirculation system, non-demand control options. They do not incorporate a demand control strategy to minimize recirculating pump operation. It includes uncontrolled continuous recirculation, timer control, temperature control, and time and temperature controls. These are known to save water, since hot water is much closer to the use points, but the energy impact can be very high in a poorly designed or controlled systems. For the installation criteria, all piping used to recirculate hot water must be insulated to meet the mandatory requirements. For systems serving a single dwelling point, the recirculating loop within a dwelling point must be laid out to be within 8 feet of all hot water fixtures serves as the recirculating loop. Piping in a recirculation system cannot be run up to the attic and then down to the points of use on the first floor.
Number 6. Recirculation system. Demand control. Uses brief pump operation in response to a hot water demand signal to circulate hot water through the recirculation loop. The system must have a temperature sensor typically located at the most remote point of the recirculation loop. The sensor provides input to the controller to terminate pump operation when the sense temperature rises. Push-button control is preferred from a performance perspective, since it eliminates false signals for pump operation that an occupancy sensor could generate. Installation criteria. All criteria listed for continuous recirculation systems apply. Number 1. Piping in a recirculation system cannot be run up to the attic and then down to points of use on the first floor. Pump startup must be provided by a push-button flow switch or occupancy sensor. Pump shut-off must be provided by a combination of a temperature-sensing device that shuts off the pump when hot water reaches the location of use, and by a timer which limits maximum pump runtime to 2 minutes or less. There are 4 types of systems serving multiple dwelling units. Number 1. Multiple dwelling units. Central demand recirculation system or standard distribution system. It brings hot water to different parts of the building, and a demand control which automatically shuts off the recirculation pump when the recirculation flow is not needed. In summary, central recirculation systems include 3 components: the recirculation loops, branch pipes, and pipes with dwelling units. Number 2. Multiple dwelling units. Recirculation temperature modulation control. It can reduce the hot water supply temperature when hot water demand is determined to be low by the control system. The sum of temperature reduction by the control in each hour within a 24-hour period shall be more than 50 degrees Fahrenheit to qualify for the energy saving credit. Number 3. Multiple dwell units, recirculation continuous monitoring systems. Systems that qualify as a recirculation continuous monitoring system
for domestic hot water systems serving multiple dwelling units shall record no less frequently than hourly measurements of key system operation parameters, including hot water supply temperatures, hot water return temperatures, and status of gas valve relays of water heating equipment. Number 4. Non-recirculating water heater system. Multi-unit buildings may also use systems without a recirculation system if the served dwelling units are closely located so that the branch pipes between the water heating equipment and dwelling units are relatively short. Mandatory requirements for distribution systems. Number 1. Pipe insulation for all buildings. Mandatory requirement in the following cases. Letter A. The first 5 feet of hot and cold water pipes from the storage tank or water heater. Letter B. All piping with a nominal diameter of 3/4 inch or larger. Letter C. All piping associated within a domestic hot water recirculation system regardless of the pipe diameter. This excludes branches off of the recirculation loop that are less than 3/4 inch diameter or do not serve the kitchen. Letter D. Piping from the heating source to a storage tank or between tanks. Letter E. Piping buried below grade. And letter F. All hot water pipes from the heating source to the kitchen fixtures. Piping exempt from the mandatory insulation requirement includes: Letter A. Factory installed within space conditioning equipment. Letter B. Piping that penetrates framing members is not required to have insulation where it penetrates the framing. However, if the framing is metal, then some insulating material must prevent contact between the pipe and the metal framing. Letter C. Piping located within exterior walls which is installed so that piping is placed inside of wall insulation does not need to be insulated if all the requirements for insulation installation quality are met. Letter D. Piping located in the attic does not need pipe insulation if it is continuously buried by at least 4 inches of blown ceiling insulation. Piping may not be placed directly in contact with the sheetrock and then covered with insulation to meet this requirement. Letter E. Piping that serves process loads, gas piping, cold domestic water piping, condensate drains, roof drains, vents, or waste piping.
Other installation information. Letter A. No insulation should be installed closer than 6 inches from the flue. If possible, bend the pipe away from the flue. Otherwise, it may be necessary to stop pipe insulation short of the storage tank. Letter B. All pipe insulation seams should be sealed. Letter C. Installed piping may not be located in supply or return air plenums. Letter D. Hot and cold water piping, when installed in parallel runs, should be a minimum of 2 inches apart. Letter E. If a firewall interrupts the first 5 feet of the pipe, the insulation may be interrupted at the wall and continued on the other side. Letter F. Insulation for pipe elbows should be metered and insulation for teeth should be notched. Where insulation is required as described above, 1 inch or R4 insulation is typically required. This requirement applies to domestic hot water pipe when the pipe diameter is 2 inches or smaller, the water temperature is between 105°F and 200°F, and the insulation conductivity between 0.24 and 0.28 British thermal unit inches per R square feet degree Fahrenheit. 1 1/2 inch insulation is required on pipes greater than 2 inches. For insulation protection, if hot water piping insulation is exposed to weather, it must be suitable for outdoor service. For typical cellular foam pipe insulation, this means protection with aluminum, sheet metal, painted canvas, plastic cover, or a water-retardant paint coating that shields from solar radiation. Insulation must be protected by an external covering unless the insulation has been approved for exterior use using a recognized federal test procedure. Distribution system serving multiple dwelling units with recirculation loops. Multi-family building may have individual water heaters for each unit, but they are more likely to have a central water heating system with a recirculation loop that supplies each of the units. This recirculation loop is comprised of a supply portion of larger diameter pipe connected to smaller diameter branches that serve multiple dwelling units, guest rooms or fixtures, and a return portion that completes the loop back to the water heating equipment. The large volume of water which is recirculated during periods of high use creates situations that require the installation of certain controls and servicing mechanisms to optimize performance and allow for lower cost of maintenance. The following are the requirements of systems serving multiple dwelling units and with recirculation loops. Air release valves. The constant supply of new water in combination with the continuous operation of pump creates the possibility of the pump's cavitation due to air in the water. Cavitation is the formation of bubbles in the low-pressure liquid on the suction side of the pump. The cavities or bubbles will collapse when they pass into the higher regions of pressure, causing noise and vibration, which may lead to damage to many of the components. In addition, there is a loss in capacity and the pump can no longer build the same head. Ultimately, this impacts the pump's efficiency and life expectancy. Cavitation shall be minimized by either the installation of an air release valve or mounting the pump vertically. The air release valve must be located no more than 4 feet from the inlet of the pump. The air release valve must be mounted on a vertical riser with a length of at least 12 inches. Backflow prevention. Temperature and pressure differences in the water throughout a recirculation system can create potentials for backflows. This can result in cooler water from the bottom of the water heater tank and water near the end of the recirculation loop flowing backwards towards the hot water load and reducing the delivered water temperature. To prevent this from occurring, the standards require that a check valve or similar device be located between the recirculation pump and the water heating equipment. Equipment for pump priming or pump isolation valves. Repair labor costs can be reduced significantly by planning ahead and designing for easy pump replacement when the pump fails. To meet the pump priming equipment requirement, a hose bib must be installed between the pump and the water heater. In addition, an isolation valve shall be installed between the hose bib and the water heating equipment. This configuration will allow the flow from the water heater to be shut off, allowing the hose bib to be used for bleeding air out of the pump after pump replacement. Connection of recirculation lines. Manufacturer's specifications should always be followed to assure optimal performance of the system. The cold water piping and the recirculation loop piping should never be connected to the hot water storage tank drain port. Backflow prevention in cold water supply. The dynamic between the water in the heater and the cold water supply are similar to those in the recirculation loop. Thermosiphoning can occur on this side of this loop just as it does on the recirculation side of the system. To prevent this, the standards require a check valve to be installed on the cold water supply line. The valve should be located between the hot water system and the next closest T on the cold water supply line. Distribution system compliance limitations. Number 1. pipe insulation. Insulation must meet the level required in the mandatory requirements. Note that pipes buried within ceilings or wall insulation can meet the mandatory requirements. Number 2. Heat tape. If an electric resistance heating tape or heat tape is wrapped around hot water pipes, must be used only for freeze protection and cannot be used instead of mandatory pipe insulation or pipe insulation receiving distribution credit.
To sum up, domestic water heating is now becoming a widely used internationally and most preferred by the people. It is very essential that as a future civil engineers, we are able to engage ourselves in the different types of it and how it functions individually. Through this, we became aware of what may be the best temperature for a certain place when designing water heater. We also discussed a different method of proper sizing of a water heater and how to determine the estimated supply of hot water needed in accordance to the periods of peak use. Today, we also gain knowledge on what type of water heater best suit for our home with deeper analysis of its cost, benefits, and how it affects the environment. So that's all for our report for today. I hope you learned something.